In this video, we're going to talk about logarithmic graphs. So there are two different logarithmic graphs. We have growth and decay. Let's first analyze the logarithmic growth. This is for f of x equals log base b of x when b is greater than 1. And so you can see the graph drawn. So the domain for this function must be from 0 to infinity because there are no values of x less than 0. There's no negative x values. And 0 is also not a possible value for x. For the range, we have negative infinity to infinity because there are no value of y that we can't have, so all the values of y are possible. The x-intercept we can see is already on the graph is 1, 0, where the graph crosses the x-axis. There is no y-intercept because the graph never touches the y-intercept. So that means the asymptote must be the y-axis. Now looking at the logarithmic decay, which is f of x equals log base b of x for b between 0 and 1. So in this case, the domain is the same because there are no values of x for 0 and the negatives. The range is also the same as all values of y are possible. The x-intercept is 1, 0 as shown in the graph, where the function crosses the x-axis. The y-intercept is none because there is no time that the function crosses the y-axis, which means the y-axis also must be the asymptote. So as you can see, the really only difference between the logarithmic growth and decay is the direction of the function, but the domain, range, x-intercept, y-intercept, and asymptote are the same for both. So now we can have transformations of our y equals log base b of x. One possible transformation is k of x equals log parentheses x minus h. So in this case, you would move right h units. And if in parentheses you had x plus h, you would do the opposite and move left h units. If you were given m of x equals negative log of x, this causes a reflection across the x-axis. H of x equals log of x plus k means you move up k units. A minus k would move down k units. And lastly, p of x equals b times the log of x means you expand vertically by a factor of b. So let's do an example. We're asked to describe the transformation of g of x equals negative 2 times the log of x plus 5 from the original f of x equals log of x and graph them. So first let's analyze the negative out in front. And we know when we have a negative in front, we will reflect across the x-axis. The 2 times the log of x, we can use the last transformation we used, which was p of x equals b times log of x. So this means we're going to expand vertically by a factor of 2. And the plus 5 on the end, we will use the h of x equals log x plus k rule, and we will move up 5 units. So our original graph of our function will look like this. So now we know we're going to expand vertically by a factor of 2. We're going to reflect this across the x-axis and move up 5 units. So we know that that point will be up 5 units And we have flipped this, so instead this is coming from this direction. So this is our log, our original, and this is our -2 log x plus 5.